Hello Year 11, it's Mr. Green again. I'm going to take you through the second lesson of the second topic of Year 11. This is waves, and our learning objective today is to describe the main features of a wave. So our learning objectives today would be to know what the amplitude, wavelength, frequency and the period of a wave are, be able to show the amplitude and wavelength in a diagram of a wave, and be able to calculate the period of a wave given the frequency. So when we represent waves, this is a quick diagram. There'll be a better one along in a second for you to copy down. But a wave can be represented on a set of axes like a graph, and a line is drawn to show the displacement of particles from their positions at a moment in time. So if there wasn't a wave happening on here, all those particles would be along the horizontal line you can see going through the middle. When we have a wave, that particle is disturbed from where it should be, and it moves up and down in a given time. That displacement is given on the left hand side of the graph. So we can see the movement of that. The particle has moved from its rest position to these points that you can see on there. The highest point it moves would be called the crest of the wave, and the lowest point it goes to is called the trough. That's a slightly better diagram showing it. If we can see the wavelength there is the distance between two crests. We have something there as well called the amplitude. That is the maximum disturbance from the centre of the wave. That's referred to as the amplitude. So if you could pause the video, just copy that diagram down. Okay, here's some definitions for you. Again, if you'd like to pause the video and copy these definitions down, I'll just go through them very quickly. So the amplitude of the wave is the maximum displacement of a point on the wave from its undisturbed position. So in other words, it's the distance from the undisturbed position to a crest or a trough. Crest is the highest point of the wave, trough is the lowest point of the wave. The wavelength, that's the distance between two successive crests, or two successive troughs. So the distance between two of the exact same points on the wave, that would be the wavelength. That's measured in meters. And the frequency, that's the number of waves that pass by a certain point per second, and we'd measure that in hertz. We can see from the graph there, one complete wave is one peak and one trough. So the waves we have on that diagram there are not quite 2, it's about 2 3/4. So just under 2 waves on that diagram there. On our previous slide, that was 2.5 waves on there. So a peak to a trough, peak to a trough, peak. Okay, if you pause it there and make sure you copy those down for me. Okay. Longitudinal wave is slightly different because, again, the particles move from side to side rather than up and down. So in a longitudinal wave, a wavelength is the distance between two centres of successive compressions. So we'd have a compression on one end, a compression on the other, and a rarefaction in the middle. The distance between those two compressions will be referred to as the wavelength. Okay, quick question for you here. If these waves were happening in the time periods we see at the side there, what would their frequency be? Remember, frequency is number of waves per second. So count the number of waves that we have there, and again, that's at the bottom, that's how much time it's taking. So if those waves happened in 2 seconds, how many waves would there be per second is what it's asking. Give you a minute to try and work those out. Again, pause the video if you need some time to work it out. Okay, so the answers to this one are in 1 second. So if we're saying that's happening in 1 second, we have 1, 2, 3 waves. So 3 waves in 1 second. If that was taking place in 2 seconds, we'd have to divide that 3 by 2, giving us 1.5. If that was happening in 10 seconds, we'd have to divide that 3 by 10, giving us 0.3 waves per second, or 0.3 hertz. If it was 0.5 seconds, that's 3 divided by 0.5, giving us 6 hertz. And finally, 0.2 seconds, that would be 3 divided by 0.2, giving us 15. Again, pause the video, ensure you've got those answers down, and make sure you know how I've got to those figures. It's always the number of waves at the top divided by the time in seconds. Okay, now the time period of a wave, that's the time it takes for a full cycle of waves to be completed. So it's the length of time between one crest passing a point and the next crest passing a point. It's the amount of time for one wavelength to pass a certain point. And we find the period of a wave from its frequency. And is this the equation that we use? You need to copy this equation down because you will need to use it. The time period is equal to 1 divided by the frequency. Pause the video to ensure you've got that down. Okay, I'll give you an example. So a boy measures the frequency of an ocean wave as 0.2 Hz. Calculate the period of this wave. So time period is 1 divided by frequency. The frequency is given as 0.2, so it's 1 divided by 0.2. If you put that in your calculator, it comes out as 5. Time period is always in seconds, so that would be 5 seconds. Again, when you are writing out your answers, when you're writing out any equations or calculations, make sure you stick every step in there. You've got your equation, calculation, then your answer, with units at the end of it. Okay, quick few questions for you. If you pause the video, take a few minutes to answer these questions. So if you take a pause now and answer those 4. Okay, so answers. Amplitude of a wave is the maximum displacement of a point on the wave from its undisturbed position. The wavelength is the distance between the same point on 2 adjacent waves. You could have said from crest to crest or trough to trough. The frequency is the number of waves that pass a certain point every single second. And the period is the time taken for one cycle of a wave to be completed. Again, pause the video to ensure you've got those answers. Okay, further questions. So, the diagram below shows a man shaking a spring up and down to produce a wave. What's the wavelength? And question 2, an oscilloscope is used to display the wave below. What's the amplitude and period? And calculate the frequency. Pause the video whilst you attempt those questions. Okay, question 1. If we can see, that's 2 meters from the spring to the wall, but that's only half a wave we can see there. It hasn't gone back to its original position. So if half the wave's 2 meters, that would be 4 meters. So the wavelength is the full cycle. The distance on the diagram is only half a cycle. Wavelength twice that distance, so it would be 4 meters. Question 2. Amplitude. How many spaces has it gone up? It's only gone up to 1 centimeter, so the displacement there would be 1 centimeter. That's the highest point it's reached. Okay. Period, how long for one wave? So it goes up, down and back up again. That takes 4 seconds for one wave to be completed. You could even go between peak to peak. That's between 1 and 5. That'd be 4 seconds. We haven't got 2 troughs to do though. So peak to peak or from the start to 4 seconds. What's the frequency of the wave? So again, we know we've got one wave in 4 seconds. So how many waves per second? Frequency equals 1 over time period, so 1 divided by 4 gives us 0.2 Hz. You have to rearrange that equation. Again, pause the video, take the answers down. Okay, there is a worksheet provided with this. If you would pause the video, it's the end of the lesson for this point, and attempt worksheet number 1 for me, please. There's quite a few questions on there. Try and work your way through those. Okay? Thank you very much. Goodbye.